Hello? Okay, finally. Oh dear. I forgot to change the stream title and category again, but now that's been fixed. A bit late, but we're gonna get immediately into suffering. Welcome back. Anyways, today we got two kind of unrelated subjects. We got area and length of polar curves, and then we got sequences. Area and length of polar curves. Let's get started. Number one says find area. R is equal to e to the power of negative theta over 4. And theta is between pi over 2 and pi. Find area. Okay, for polar curves, the area would be defined by the integral from somewhere to somewhere of 1/2 f of theta squared d theta, where r is equal to f of theta. All right. Let's write this a equals. Now then plug everything in, we get integral from pi over 2 to pi. 1/2 of that. We can take constants out, and then e to the power of negative theta over 4 squared d theta, which simplified a bit, we get pi over 2 to pi of e to the power of negative theta over 2 d theta, which is equal to 1/2. That should be what? Negative 2 e to the power of theta over 2. Oh, negative theta over 2. By the looks of it. And it goes from pi over 2 to pi. Solve that, we get negative. Or rather, let's not do that just yet. Or maybe we can. So that's negative. Take the 2 and 1/2, factor them out. E to the power of negative pi over 2 minus e to the power of negative pi over 4. So we get e to the power of negative pi over 4 minus e to the power of negative pi over 2. And that's a pi right there. That appears to be it. Followed by number 1, of course, is number 2. Lining up perfectly. Number 2, same thing, but this time r is equal to sine of theta plus cosine of theta. Theta is between 0 and pi. Find area. All right, same thing here. We take 1/2, then integral from 0 to pi of, this time it's sine theta plus cosine, right? Plus cosine theta squared d theta. A bit more complicated. Take 1/2 from 0 to pi of sine squared theta plus cosine theta sine theta plus cosine squared theta d theta. Sine cosine is equal to 1. Sine squared plus cosine squared, so equal signs. This is equal to 1 to 2 from 0 to pi of 1 plus sine theta cosine theta d theta. And integral of sine theta cosine theta is, hang on, am I thinking about this right? Sine 1/2 sine squared theta. Let's test it out. Theta plus 1/2 sine squared theta. Yeah, that should be right. Since if we say sines u, then cosines du. So we get 1/2 u squared. And this goes from 0 to pi. Plug in 0, we get 0, therefore plug in pi, we get pi over 2. Sine of pi is 0, right? Pi over 2, that's right. Okay. Next up is number 3. Oh yeah, did we forget to... I think we forgot something. Okay. What's Forrest Gump's Facebook password? 1Forrest1. I don't get it. Huh? What's Forrest Gump's Facebook password? 1Forrest1. What's so special about 1Forrest1? I'm not thinking like a dad enough for this. Alright, we don't have number 3. The previous one was number 3. Anyways, this dad joke gets a 1 out of 10. I don't get it. Maybe that's just my lack of dadness, but I don't get it. Number 11 says r is equal to 3 plus 2 cosine theta. That's a cardioid. And it says sketch and find area. Let's do sketch first. Sketch easy. It can be ugly, I really don't care at this point. It's gonna look like this. I'm just too familiar with cardioids at this point. 3 plus 2, at 0 it's gonna be 5. 5, 0. And it does not collapse in on itself because 3 is greater than 2. To make a full circle, we would go to pi from 0 to 2 pi. From 0 to 2 pi. Therefore, or integral shall be 1/2 0 to 2 pi of 3 plus 2 cosine theta squared d theta. That is going to be equal to 1/2 from 0 to 2 pi of 9 plus 6, no, plus 12 cosine theta plus 4 cosine squared theta d theta. Right, yeah. That's going to be equal to 1/2 integral from 0 to 2 pi of 9 plus 12 cosine theta plus 4 times 1/2 1 plus cosine of 2 theta. Is it plus or minus? I keep forgetting this part. I think it's plus. Yeah, I think it's plus. And then d theta. Simplify that out. We get integral from 0 to 2 pi of 9 plus 12 cosine theta plus 2 So let's take the 2 out. 2 can go with 9 to form 11. Plus 2 cosine 2 theta d theta. Now take the integral, we get 1/2 11 theta plus, plus 12 sine theta plus sine 2 theta from 0 to 2 pi. Plug in 0, you get nothing, so that's equal to 1/2 times 22 pi. Wait. Equals 11 pi. Since you plug in 2 pi, you also get 0 for all the signs. Yep, it is 11 pi. Next up, when work gets long, I have trouble lining up all my numbers. Starts here. Next up is number 17. 17 is r is equal to 4 cosine 3 theta. Find area of one loop. Now, 3, that's an odd number. Therefore, we have exactly this number of loops. So from 0 to 2 pi, we got 3 loops. Therefore, one loop is pi over 3, and half a loop is pi over 6. Therefore, I can say we have 1/2, or rather 2 times 1/2, because we have 2 half loops from 0 to pi over 6. Hang on. 2 pi divided by 3. 2 pi divided by 6. So pi over 3. Yeah. Pi over 3 of 4 cosine 3 theta squared d theta, which is equal to integral from 0 to pi over 3 of 16 cosine 3 theta squared d theta, which is equal to integral from 0 to pi over 3 of 8 times 1 plus cosine of 6 theta d theta, which is equal to 8 theta plus 8 over 6, so 4 over 3 sine of 6 theta from 0 to pi over 3. Plug in 0, get nothing. Plug in pi over 3, you get 8 pi over 3 plus sine of sine of 6 pi over 3, that's sine of 2 pi with 0. Number 17. It looks like it didn't do it quite right. Hang on. It might have to do with my bounds. If it was pi over 6, then it would be right. Let me confirm something real quick. We go from 4 cosine 3 theta wait. Yeah. I forgot. Pi over 3 is 2. Pi over 3 is 2 hoops. So there's two ways I can fix this. The easier way would be to just remove that 2 there, and now we just get 1/2. And that will be equal to 4 power 3. I forgot. It goes in a full 3 leaf. It makes 3 loops. That doesn't look right. It makes 3 loops in 0 to pi. So half of a loop would be pi over 3. No, pi over 6. One full loop would be pi over 3. Well, then next up. Next up we got 17. No, we just did 17. So next up we got 19. 19 says r is equal to sine of 4 theta. 4 is an even number, therefore we multiply by 2. There are 8 loops in this graph. Find area of one loop. Now since we have 8 loops, one loop will be pi over 8. Therefore we want 2 times 1/2 times from 0 to 1 over pi over 16. That would work. 1 over 6 pi over 16 of sine squared for theta d theta, which is equal to integral from 0 to pi over 16 of 1 minus cosine 8 theta over 2 d theta, which is equal to 1/2 theta plus 1/8 sine theta, right? Thank God, no. I'm confusing myself a little. Yeah, minus. And it goes from 0 to pi over 16. Also, that's sine 8 theta. My bad. Sine of 8 theta. Therefore, you get 1 over 2. Plug in 0, you get 0. Therefore, plug in pi over 16. Pi over 16 minus 1 over 8. So that's sine of pi over 2. Sine of pi over 2 is 1. So we get minus 1/8. Equals pi over 32 minus 1 over 16. That just doesn't feel right. Yeah, that doesn't feel right. Sine of 4 theta 8 loops. Hey, yeah, I did play Global Corp. The final day was really trippy. The final day felt weird. Oh, wait. I think I know what problem this is. Oh, this is sine, that's right. Zoomed out to see it in action. Yeah, I think the video is published, right? Correct me if I forgot to publish it. Don't need to day 1. I don't know how we somehow beat Bina. We got the worst RNG, but then somehow still beat Bina. And it ended up in 34 dead employees, which is quite a lot. But this was my fault that this shouldn't be pi over 8. Pi over 8 is half a loop here. And fix this as well. You're expected to have your whole facility wiped by Bina. You better remember calculus. You probably recognize theta. Hit most of it except differential equations. Well, we're about to have sequences next, and I think sequences is actually something that's quite fun. Power 8 and minus 0. So that is pi over 16. Is that right? Yeah, for calculus, you just need to remember a couple things and you pretty much know everything. X to the power of n, you take n times x to the power of n minus 1, and the integration, you just do it in reverse. You remember these two and you basically know half of calculus. But the next chapter is going to be sequences, which I actually find pretty fun because it logically makes sense. It's like a puzzle. And though memorize and understood, it still feels bad. Yeah, I get that. Sometimes you just see a question, you have no idea what to do with it. R is equal to 4 sine theta. R is equal to 2. Find area outside first R inside second R. Let me finish writing this. Oh my god, that's long. Oh. It does get really confusing sometimes. Now, outside of first R, inside of second R, I'm gonna graph this first. For sine theta, that's gonna be a circle of diameter 4, and it goes up. Calculators have arcsine. Yes, they do have arcsine. So the first equation is gonna be like that. Well, the second equation is a centered circle. And we want to find this area. Okay. To do that, let us find 4 sine theta is equal to 2. Therefore, sine theta is equal to 1/2. When is sine theta equal to 1/2? I forgot my trig. I left my trig at home. Is this pi over 3? Sine theta means the first circle. Yup. That's just something I remembered. 4 would be the diameter of the circle. And then sine means it's up or down. And it's positive, so we put it up. Now, I left my trigonometry at home. I'm gonna need to double check here. No, it's not sine of pi over 3. It's probably sine of pi over 6. Yeah, pi over 6 and... what is it? 5 pi over 6? Yep. That's R2 has no theta, so therefore it's centered around the origin. Yes. And it just means radius is equal to 2. It is so important, but I somehow fail at it all the time. We get pi over 6 and 5 pi over 6. I can draw the unit circle from memory. Oh, look at that perfect circle. I can draw it from memory, but it's kind of like the alphabet. I don't remember any of it until I recite the entire thing. If you ask me, oh, what's the letter before C, I would tell B. But if you say, oh, what's the letter before M, I wouldn't tell you until I recited the entire alphabet. And it's the same thing for me with unit circles. Until I draw the entire unit circle, I don't remember what individual coordinate is. But since we know... Okay. Plug in a random number. How about pi over 2? Plug in pi over 2, we get 4. So... kind of goes this way. I think we can do this. 2 times our integral, which is from 0 to pi over 6 of 4 sine theta squared minus 2 squared. At least a unit circle doesn't change. You get one copy of it, you can just keep it. Like, get a tattoo of the unit circle on your hand and you will have it with you forever. Now then, that would give us half of this area here, and we multiply by 2, that gives the entire area. Therefore, we have the integral from 0 to power 6 of 16 sine squared theta minus 4. Huh? What did I just do? Oh. D theta, which is equal to integral from 0 to power 6 of 8 sine, no, 8 times 1 minus cosine of 2 theta minus 4 d theta. Write it down does help. Which is equal to 4 minus 4 sine 2 theta from 0 to power 6. Write it down does help a lot. But then there's a speedrunning mindset. Do everything in your head and complete it as fast as you can. It doesn't always work out well. That's 8 minus 4, 8 cosine 2 theta, that's 4 sine 2 theta. Plug in 0, wait, oh, I forgot the theta here. Plug in 0, we get 0, therefore plug in pi over 6, we get 2 pi over 3. Sine pi over... hang on, pi over 3. Sine of pi over 3 is root 3 over 3. No, root 3 over 2. So we get minus 2 root 3. Yeah? 23, what is it? No? Ah, damn it. I was close. What went wrong here? That's a plus. And that's a 4 instead of a 2. I should have done the speed run. From 0 to pi over 6. 4 squared 16 sine squared. Divide that by 2. Starting with the easiest. Can't really tell which problem's easier or harder than another. Yeah, I can't tell which problem's easier or harder. You really don't know until you start taking it apart. Eight. Could that have been pi over 3? No. Hang on. If you take full calculus course, it will probably click. If you're taking calculus in, say, a summer class, a summer semester, where they cram everything inside like 2 months, that gets really hard. The textbook is nice, but the textbook doesn't always offer the explanations. And got pi. Plug in pi, we get 0. This goes this direction. Power 6, power 2, pi. Make a full circle at pi. Huh. Feels like my entire school is using the same textbook. Calculus Early Transcendental 8th edition? Or was it 15? Is this 1 plus? No, this is 1 minus. Find regions that lies inside the first curve. Oops. Inside first R, outside. There we go. Remove from the area the one centered on 0. That is kind of what's going on here. This is the top circle minus the bottom circle. But I've still done something wrong, that's for sure. Yeah. Wait. My graph was wrong. I found what's inside both circles. Thank you. You just made me realize the mistake. We don't want that area. We want this area. We want this area. That makes so much more sense. If that's the case, we can still reuse most of this. Except this time it's 1/2 from pi over 6 to 5 pi over 6. You saved me right there. I was wondering what was going on. Alright. Now let's just change all of these bounds. All these bounds, therefore pi over 6, 5 pi over 6, 5 pi over 6, pi over 6. Stop turning my 6 into zeros. Pi over 6, 5 pi over 6. And let's simplify that a little. That turns to 2 theta minus 2 sine 2 theta from pi over 6 to 5 pi over 6. Theta is just a variable. It's just like x, except it's round this time. I don't know why we had to introduce a Greek alphabet, but it's here. We get 5 times 5 pi over 6, that's 5 pi over 3. Hang on, am I thinking about this right? The area goes from pi over 6 to 5 pi over 6, yes. Minus sine of 5 pi over 3. Oh god, where is 5 pi over 3? Calculator time. Sine of 5 pi over 3 is negative root 3 over 3. No, root 3 over 2. So that's negative root 3. How's 4 sine theta equal 2? Oh, we're finding where they intercept with one another. When the two radius are the same, that's when the two circles intersect with each other. That's this point right here and this point right here. And then minus pi over 6, so that's pi over 3. Wait, no, not over 6. Yep. Pi over 3 minus pi over 3 minus sine of pi over 3 is root 3 over 3? Or is it... Yeah. Wait, is it negative root 3 over 3? Gotta double check. Root 3 over 3. No, root 3 over 2, but we multiply by 2. So root 3 equals 4 pi over... Wait, no, that's negative, so that's positive. 4 pi over 3 plus 2 root 3. Is that right? There we go. So you found the problem. I read the entire problem wrong. And down here, we're gonna have 27. 27 seems essentially r is equal to 3 cosine theta. That is the answer. I have the answer from the textbook. This is the same as the answer in the textbook. There is an answer key. I have it open. I can only check the answers for odd numbered questions though. R equals 3 cosine theta. R is equal to 1 plus cosine of theta. Inside first R. Outside second R. I think we only have odd numbered questions today though. I think every question's odd numbered, which is fantastic. I love that. Let's see. What are these shapes? This is a circle. This does not look like a circle. This looks like a cardioid. So we got one circle with a diameter of 3. And then we got a horizontal cardioid that can peak at 2. Have you ever heard of a cardioid microphone before? It looks like a heart. So one of these has to look like this. The second equation kind of looks like a heart. I hate my drawing. I can never do anything artistic. So we want the area over here. Now then, where these two intersect, 3 cosine theta is equal to 1 plus cosine theta. Never knew the term. This was my first time learning about it as well, I think. I don't know the name for everything, but I do know the name for cardioid. And then there's also the rose curves. I think rose curve is a flower. We haven't gotten over too much detail on that. So minus cosine theta on both sides, we get 2 cosine theta is equal to 1. So therefore cosine theta is equal to 1/2. Where is cosine theta equal to 1/2? Pi over 3. And negative pi over 3, right? Hang on, double check. Cosine of 3. Yep. Now that goes to 2 pi for the circle. At 0, its circle starts at here, and then at pi over 3 it meets here. Therefore, we can do 2 times use symmetry to our advantage. Integral from 0 to pi over 3 of outside 3 cosine theta squared minus inside 1 plus cosine theta squared d theta. Symmetry. And let me, how do I close this? Oh. Alright. That turns out to be integral from 0 to pi over 3 of 9 cosine squared theta minus 1 minus 2 cosine theta minus cosine squared theta d theta, which is 3 cosine theta is the circle, right? Inside the first one, outside the second one. Yep. Therefore, we have 0 to power 3. We take 1 cosine away, that turns into 4 times 1 plus cosine of 2 theta minus 2 cosine theta. We want it to be outside of the heart and inside of our circle. So this is outside, this is inside. Outside minus inside. And then minus 1. D theta. Which is equal to integral from 0 to power 3 of 4 cosine 2 theta minus 2 cosine theta plus 3. Yes, we want the part of the circle that the heart does not cover. Yep. Subtract the area of the heart from the area of the circle. It looks so confusing at first glance, but then it makes sense. Which is equal to 2 sine 2 theta minus 2 sine theta plus 3 theta from 0 to power 3. Plug in 0 we get nothing, therefore plug in pi over 3 we get sine of 2 pi over 3. 2 pi over 3 is how many degrees? 120. So it should be root 3 over 2, right? Just double check. Sine of 2 pi over 3 should be root 3 over 2. Yes, it is. Equals 2 times root 3 over 2. That's root 3 minus sine of pi over 3 should also be root 3 over 2. Right? Root 360. 61 is symmetric, yeah. Minus pi over 3 plus pi. Is our answer just pi? Can't be. Wait, it is! The answer is simply pi. There we go. Now then, almost done with polar. Very cool. 45 says r is equal to 2 cosine theta. 0 is between theta and less than pi. lens. I have Library of Runa on my Steam wish list. I'm just waiting. I'm thinking about whether or not to do challenge mode for library. I mean for Lobotomy Corporation. I feel like I'm not gonna do challenge mode because it's just repeating the same thing over and over. What I do want to do though is to get 100% completion on every abnormality and then get the true ending. So I think we won't be quite done with Lobotomy Corporation yet. Rushing to unlock Central. I remember there's a mod that doubles your abnormality count. I want to get that one. I want to get the mod that doubles your abnormalities and then try to go for 100% completion. Now, let's see. Polar curve lens. So yeah. Polar curve lens can be calculated by L is equal to integral from A to B, alpha to beta, of square roots of r squared plus dr d theta squared d theta. Now then, at least it gives us all the bounds right off the bat. It takes the integral from 0 to pi of the square roots of 2 cosine theta squared and then derivative. Dr d theta is equal to -2 sine theta plus -2 sine theta squared d theta. That's equal to integral from 0 to pi of square roots of 4 cosine squared theta plus 4 sine squared theta. No, calculus never truly ends. It will haunt you forever. But luckily, cosine squared theta plus sine squared theta is just 1, so therefore this is equal to 0 to pi times the integral of 2. Or rather, square root of 4 d theta, which is just integral from 0 to pi of 2 d theta, which is equal to 2 theta from 0 to pi, which is equal to 2 pi. And that's correct. Next up, says 47. R is equal to theta squared. Theta is between 0 and 2 pi. Alright, dr over d theta is equal to 2 theta. Therefore, we want the integral from 0 to 2 pi of the square roots of theta squared plus 2 theta squared d theta, which is equal to integral from 0 to 2 pi of the square root of theta to the power 4 plus 4 theta squared d theta, which is equal to I can factor out a theta. Integral from 0 to 2 pi of theta times square root of theta squared plus 4. Uh-oh. Does this have to be trig substitution? Or is there an easier way? Oh dear. Let's do it this way. We factor out a 1 over 4. So we get 1/2, 0 to 2 pi, a theta square root of theta over 2 squared plus 1 d theta. And we say u is equal to, let's say t, let's use t instead. T is equal to tangent, it's plus 1, so tangent theta over 2 dt is going to be equal to, hang on, secant squared theta over 2 d theta. Wait. No, once I stop using theta, now I'm getting confused. No. Theta is equal to tangent t. Theta over 2 is equal to tangent t. And then d theta is equal to 2 secant squared t dt. Therefore, our integral is 1/2 times integral from 0 to 2 pi of theta over 2. So theta is 2 tangent t times integral, no, times the square root of tangent squared t plus 1, which is secant t, and then times 2 secant squared t dt, which is equal to integral from 0 to 2 pi of, or 2 times that, of tangent t secant cubed t dt. Oh dear. So that would be 2 times 1 over 4 secant to the power of 4t. Oh wait, we don't know the bounds anymore. From somewhere to somewhere. Right, because derivative of secant is secant tangent. Wait, no. 1/3. Now this should be right. Draw a little triangle. Angle T is equal to, or the tangent of T is equal to opposite of adjacent. This is theta squared plus 4. Secant is adjacent over hypotenuse. No, hypotenuse over adjacent. So that would be 2/3 of square root of theta squared plus 4. Wait. Okay. Over 2 to the power of 3 goes from 0 to 2 pi. Back down the 2, we get 1 over 12 times theta squared plus 4 times square root of theta squared plus 4. from 0 to 2 pi. Oh dear. Why is this so long? Alright, let's write it uh-oh. There we go. Let's write it a slightly different way. Zeta squared plus 4 to the power 3 over 4 from 0 to 2 pi. Plug in 2 pi, we get 1 over 12. 4 pi squared plus 4 to the power of 3 over 2. This should be a 2. Minus, plug in 0, we get 2 power 3, 8. So ultimately we would get 1/3 times pi squared minus 1. No? Wait, no. I can't just factor things out from here, I just realized. Hang on. We can factor out a 4. So that's 2. Wait. We factor out an 8. And then we get pi squared plus 1 minus 8. Which is equal to 2 over 3. That's power 3 over 2 times pi squared plus 1 to the power 3 over 2 minus 1. Wait, 8 over 12, 2 over 3, yeah. And that looks like it's not it. It had a 8 over 3 instead of a 2 over 3. Problem probably comes from here. Zeta over 2 is equal to tangent t. Oh, I see the problem. Instead of a 2, this should have been a 1/2. Which means out here, we would have had a 1/2. Divide everything by 4. Wait, no. No. That's not it. Zeta is equal to 2 tangent t. D zeta is equal to 2 secant squared t. Did I do something wrong here, perhaps? Ah. Opposite over adjacent is pi over 2. I factor out a 2 here. Wait. Oh. But 2 to the power of 3, that's 8. Won't really help if factor out an 8. I did factor out an 8. Get 2 pi, plug in 2 pi, get 2 pi squared. I'm gonna look this one up. This is square root theta squared r to the power 4 plus 4 theta to the power of 2 goes from 0 to 2 pi. Huh. It seems like I have done the integration wrong at one point. Wait, we didn't have to do trig sub. Trig sub wasn't needed here. There's a different way to do it. Oh dear God. All this for nothing. But trig sub is most certainly a way to do it. If I did trig sub, what was wrong? Boo. Where did I get this 1/2 from? This is not 1/2, that's 2. That's the whole problem. That's not a 1/2, that's a 2. So this turns into an 8. That turns to 8. That turns to 8 over 3. That turns into 1/3. It's all turned to 1/3. And this one turns into 8. That was a problem. Another simple algebra mistake ruins the day. Let me make it a little easier to read. The power is 3 over 2. That was the whole problem. Come on. Now then, let me write the title for the next one. 11.1. That's right over here. 11.1. Sequences. What kind of sequences? Forgot. 11.1. Doesn't seem that bad. Should have enough space. Our first problem is number 11. That's a lot of ones. Number 11 says a of 1 is 2. and a sub n plus 1 is equal to a sub n over 1 plus a sub n. First 5 terms. Oh, that one's easy. The first one's already given. We got 2. And 2 over 3. And then we got, oh, you might know the problem now. So a sub 3 is going to be a sub 2. 2 over 3 over 1 plus 2 over 3. So that's 5 over 3. Multiplied by the reciprocal, we get 2 over 5. Then we got 2 over 5 over 1 plus 2 over 5, which is 7 over 5. Huh. So this would go 2 over 7, 2 over 9 if I'm correct. Number 11, and that's right. This is how it goes. That was easy, but next one, 21, says a sub n is equal to 1 plus negative 1/2 to the power of n. Calculate to the 4 decimal places the first 10 terms of the sequence. Oh, oh no. Calculate first 10 terms and graph or and plot. Oh, has limit. Find the limit. All right. Yes, my calculator should have a table function. But I think I know a better way to do this. 1 plus negative 1/2 power of n. This function definitely does have a limit. All right. Wait. Well, whatever. I'll just do this the hard way. 1 plus negative 0.5 to the power of wait. How does this work? Come on. All right, first 10 terms, 0.5. Why do we need this question? 1.25 0.875 1.0625 0.9687 or to 4 decimal places. 1.01563. Nah. 4 places. 7 is 0.9922. 8 is 1.0039. 9 is 0.9980. And finally 10 is 1.00010. If we plot them, it will look kind of like can I get a straight line here? Like that. It look like, let's say this line's 1. Zero 0.5, 1.25, 0.9, 0.8 something, and it just gets closer and closer until it's pretty much on the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the limit as n approaches infinity of or sequence is equal to 1. That entire thing should have to be the answer. Next up is 29. Now for all of these below, we determine the convergence. And if converge, find limit. So 29 says the sequence a sub n is equal to e to the power of -1 over the square root of n. The limit as n approaches infinity of e to the power of -1 over n. Now, if n is infinity, then -1 over infinity goes towards 0. And if it goes towards 0, n to the power of 0 is 1. So this is 1. This is converge. This is 29, that's right. Next up is number, oh my god, does this one not look pleasant. (31) a sub n is equal to the square root of 1 plus 4n squared over 1 plus n squared. The limit as n approaches infinity of this thing. Can we simplify? I know what this is going to be. is going to be equal to how do I describe this so? Because it's the coefficient is 4 here and the power is going to be just n. The powers are equal, so we divide the coefficients. This would be 2. It has to be equal to 2. But how do I describe that? Do I have to solve this entire thing? I don't want to. Can I just say that the limit is going to be the same because 1 doesn't matter? I can't really say that. It's going to be equal to 4 times infinity squared over infinity squared, which equal to 2 times infinity squared over infinity squared. These two infinities have the same sides. And I'm just gonna say it's 2 and converge. Let me put it down below. I'm guessing you're supposed to actually solve this by using L'Hopital, which would take a very long time. Now, next up we have 33. 33 says a of n is equal to n squared times square root of n cubed plus 4n. Well, power on top is 2, power on bottom is 3 over 2. The power on top is higher. Therefore, the limit as n approaches infinity of a sub n is going to be equal to infinity. Divergent. Oh, what did I just click again? 35. 35 says a sub n is equal to -1 to the power of n over 2 to the 2 times square root of n. That's gonna be 0. Limit as n approaches infinity, because top is either 1 or -1, but the bottom gets bigger and bigger over time. That's gonna be 0. And it converges because we have a finite limit. Then for 37, we got the sequence of 2n minus 1 over 2n plus 1. These are factorials. I'll limit as n approaches infinity of 2n minus 1 factorial over 2n plus 1 factorial is equal to, oh god, infinity minus 1 factorial over infinity plus 1 factorial. And because we're multiplying by infinities here, the bottom will be an infinite time larger, therefore this is 0. The limit as n approaches infinity of, or sequence, is equal to 0 and it converges. Box that in. Next up, 39. 39 has a sequence sine of n. Well, this one has to diverge. But how does it? Diverges. It's sine, so it goes from between positive and negative 1. It oscillates between positive 1 and negative 1. Therefore, there is no limit. Therefore, it diverges. Well, let's say limit as n approaches infinity of sine n does not exist. In that case, next up's 41. 41 says we got the sequence defined by n squared times e to the power of negative n. So let's say the sequence is equal to n squared over e to the power of n. E to the power of n is gonna beat out n squared eventually. So limit as n approaches infinity of n squared over en equal to infinity over infinity. Then we do L'Hopital. And we get the limit of 2n over e to the power of n, still infinity over infinity. We do L'Hopital again. We get limits as n approaches infinity of n over, no, of 2 over e to the power of n, which is equal to 0. Therefore, limits as n approaches infinity of n squared times e to the power of negative n is equal to infinity. It converges. These questions are really fast. They don't take a lot of time to solve. But we do have a ton of them. And next up is going to be 43. 43 says a sub n is equal to cosine squared n over 2 to the power of n. That's going to be 0. Limit as a approaches, no, as n approaches infinity of the sequence is equal to 0, because cosine squared n is always going to be between 1 and negative 1. But the bottom just keeps growing. Therefore, this one has to be equal to 0 and converge. All right. 45. 45 says a sub n is equal to n times sine of 1 over n. Oh dear God. Reverse L'Hopital. Let's say a sub n is equal to sine of 1 over n divided by 1 over n. Limits. Let's do it this way. Limits as n approaches infinity of this is equal to sine of 0 over 1 over infinity. It's 0 over 0. And then we can L'Hopital. And that's gonna give us cosine of 1 over n times negative n to the power of negative 2 over negative n to the power of negative 2, and that cancels out. Perfect. And that is going to be equal to 1. So limit as n approaches infinity of our sequence is equal to 1, and this converges because it's finite. Why did I put an S here? Then we got 47. 47 says 8 of n is equal to 1 plus 2 over n to the power of n. Plug in infinity, we get 1 plus something to the power of infinity. How about this? Y is equal to 1 plus 2 over x, or 2 over n to the power of n. Natural log of y is equal to n times natural log of 1 plus 2 over n. Would that help? And then y is equal to e to the power of n times natural log of 1 plus 2 over n. But that still wouldn't work. How do I do this? N's infinity, natural log of 1 is 0. Reverse L'Hopital. 1 over n divided by 1 over n. Hang on, let me try this. Y is equal to n plus 2 over n squared to the power of n. Natural log of y is equal to n natural log of n plus 2 over n squared, which is equal to n times natural log of n plus 2 minus natural log of n squared. That still doesn't help. We need to find the limits as n approaches infinity of n times natural log of 1 plus 2 over n. And we can rewrite this as limits as n approaches infinity of natural log of 1 plus 2 over n over 1 over n, which is equal to 0 over 0. And then we go L'Hopital. Then this would be equal to limit of n as n approach infinity of 1 over 1 plus 2 over n over negative n to the power of negative 2, or negative 1 over n squared, which is equal to the limit as n approaches infinity of negative n squared over 1 plus 2 over n. It rewrites that limit as n approaches infinity of negative n squared divided by n plus 2 over n. Equals limit as n approaches infinity of negative n to the power of 3 or n plus, wait, this can't be right. We got, what's the answer? E to the power of 2, so this needs to be equal to 2, but this currently does not equal to 2. I'm gonna need some help with this. Okay, so I am supposed to do this. Then did I do my math wrong? Wait. I took my derivative wrong. I can't see my pen. Okay. What? So we got an approach infinity of one plus 2 over n negative 2 n to the power of negative 2 1 plus 2 over n over negative n to the power of negative 2. Is that what it's getting at? Oh my dear God. How does it get this complicated? Let's simplify. Approach infinity of multiplied by reciprocals 2 over 1 plus 2 over n, which is equal to 2. Then limit as n approach infinity of a sub n is equal to e to the power of 2. Because we took the natural log here. So if we e both sides, we exponentiate both sides with e, it's equal to e to the power of 2. And this converges. Alright, that was the hardest problem so far. It'll only get worse as time goes on. But 49. A sub n is equal to a natural log of 2n squared plus 1. I do not like this. minus natural log of n squared plus 1. You know what, this is not too bad. I know how to solve this one at least. This is equal to a sub n sequence is equal to natural log of 2n squared plus 1 n squared plus 1. Limit as n approaches infinity of a sub n is equal to natural log of 2. Because the limit of the inside is going to be equal to 2. Therefore, we just put the natural log there. And this converges. Remove the s. Next up, 51. A sub n is equal to arctan, arctangent of natural log of n. Okay. The limit as n approaches infinity of the sequence. Natural log of infinity is infinity. Arctangent of infinity is pi over 2. At least that one wasn't so bad. And boxing answers. Oh. Okay. So we're done with this section. Next up, we have to determine if increase or decrease if and if sequence is bounded. All right, the first one from this section is 73, which says a sub n is equal to 1 over 2n plus 3. Well, this one's going to be decreasing and bounded. Because as n gets higher, the number gets lower. A sub n gets lower. And limit as n approach infinity of the a sub n is going to equal to 0. So if n is equal to 1, then a sub n is equal to 1 over 5. And this is bounded. This is decreasing. Decreasing. Bounded. And I'm not gonna bother differentiating it. 75, a sub n. Wait, is that correct? Yes, it's correct. A sub n is equal to n times -1 to the power of n. It goes positive, negative, positive, negative, positive, negative. So this is non-monotonic. And limit as n approaches infinity of a sub n does not exist. Because it goes higher and higher, the magnitude goes higher and higher. So this is how to say monotonic and not bounded. It goes towards infinity. It does not have an upper and lower bound. Finally, we have 77, which says a sub n is equal to 3 minus 2 times n times e to the power of negative n. Okay. Well, let's find out. We need to find the derivative of this. dn ddn of n times e to the power of negative n is equal to n times e to the power of negative n, or is it negative that, minus, no, plus e to the power of negative n. Which is equal to e to the power of negative n, or rather e to the power of n, 1 minus n over e to the power of n. And if n is bigger than 1, the slope is always negative. The slope is either 0 or negative when n is greater than or equal to 0. No, when n is greater than or equal to 1. Therefore, if we have negative 2, that's increasing. The slope would be always increasing. How about limits? Limit as n approach infinity of 3 minus 2 n times e to the power of negative n is equal to how do I solve this? Right, let's solve the limit without the 3 first. And without the minus 2. That would be equal to limit as n approaches infinity of n over e to the power of n. Which is equal to 0 because exponents go higher if we use L'Hopital. So let's say that's infinity over infinity. We use L'Hopital. and that is equal to limit as n approaches infinity of 1 over e to the power of n, which is equal to 0. Therefore, limit as n approaches infinity of our sequence is equal to 3. So the entire thing is increasing. And bounded. Because the slope is always increasing, because the sequence is always increasing and there is an upper limit, it's bounded. Very well, that brings us to 11.2. (11.2) is all about infinite series. Infinite series, and we got a couple problems for this one. First, we're starting off with number 15. 15 says the sequence a of n is equal to 2n over 3n plus 1. Find convergence and whether sum is convergent. So as n approaches infinity of our sequence, then the number a of n approaches 2/3, which is not 0. Therefore, oh god, what do I call it? I remember we need to therefore by the somewhat something definition. Because a limit is not 0. Let's do this. A converges. B, the sum of n's is equal to 1 to infinity of a of n diverges. A of n converges. And then 17. 17 says, oh, for the following problems, we all find sum if convergent. And we start with 17, which says our sequence is 3 minus 4 plus 16 over 3 plus, no, minus 64 over 9 plus ... I can express the sequence as a of n is equal to 4 to the power of n minus 1 divided by 3 to the power of n minus 2. And how about this? A sub n is equal to 1/3 times 4/3 to the power of n minus 1. We factor out a 1/3. And r is equal to 4/3, which is greater than 1. Therefore, this is divergent. No, 23 says we want to find the sum of n is equal to 1 to infinity -3 to the power of n minus 1 over 4 to the power of n. If I factor out a 4, wait. Irrelevant mistake, but still a mistake nonetheless. We factor out a 4, therefore we get this is equal to, our sequence is equal to (1/4) times -3/4 to the power of n minus 1. And the limit, actually, no, because r is equal to 3/4, the absolute value of r is 3/4, which is less than 1. Or sum of our sequence is equal to a, which is 1/4, over 1 minus r. So this is 1 plus 3/4. That's 7/4 multiplied by negative reciprocal. We get, no, we flip it, we multiply by the reciprocal. We get 1/7. Oh yeah, I'm gonna check out my answers real quick. 15 converge, diverge, 17 diverge, 23 1/7. Yes, perfect. Continue on towards 25. 25 says we want the sum n equal to 1 to infinity of e to the power of 2n over 6 to the power of n minus 1. Uh-oh. This is a geometric series. How do I rewrite this? e to the power of n. No, e to the power of 2 to the power of n over 6 times n minus 6 to the power of n minus 1, which is equivalent to e squared times e to the power of 2 over 6 n minus 1. And what's e to the power of 2? Is 7. So absolute value of r is equal to e squared over 6, which is greater than or equal to 1, therefore diverges. Oh, that's fine. Determine whether the series is convergent or divergent. If it's convergent, find its sum. So then we just continue. 27. This time we got 1/3 plus 1/6 plus 1/9 plus 1/12 plus 1/15 plus dot 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 dot. Or sequence is going to be, or rather, or series is going to be a sub n is equal to 1/3n. Therefore, our sum is going to be from n equals to 1 to infinity of 1/3n. Got. How do I do this? It's not a geometric series, but it is. Limit as n approach infinity of 1/3n is equal to 0. Yeah, I need to double check how to do this. If the sequence converges to L, we say the sum converges to L. If the sequence diverges, we say the sum diverges. Gotta actually check notes. Or is it infinite series? Alright, do I have an example here? Not telescoping sum, that's later. That's geometric series. Here. But that's also geometric series. Did I read the question right? Why is this one so confusing? Because it's not to a power. It's just 1 over 3n. And it says it should diverge. But this converges. Huh. I'm quite confused. Oh wait. Did I have a chart? I actually don't know. Seems quite confusing. So I can rewrite this as 1/3 times the sum of the series 1 over n. Which converges. But why does this diverge? Proof by contradiction. Huh. I have found the answer on Stack Exchange, but doesn't quite make sense yet. It says if A is equal to 1/3 n equals 1 to infinity of 1 over n, then 3a is equal to but that doesn't have any contradictions. Wait, does the series 1 over n diverge? Huh. Why does 1 over n diverge? Oh, I guess that's something I'm just supposed to remember. Then let's write since the sum of the series 1 over n diverges. Uh-oh. Lag. Help. Or sequence. Let's say sum. The given sum diverges. So that was way too long, one question. Next up, 29. We want the sum from n equals to 1 to infinity of 2 plus n over 1 minus 2n. And limit as n approaches infinity of 2 plus n or 1 minus 2n is equal to negative 1/2, which is not equal to 0. This diverges by nth term test. Next up, 31. 31 wants sum of 3 times n plus 1 times 4 to the power of negative n. That can be rewritten as geometric. So let's do this is equal to the sum. I hate writing out all these things every time. Of 3, actually, n plus 1. So we want 9 over 4 times 3 over 4 to the power of n minus 1. Right? Plug in 1. Yep. Therefore, since the absolute value of r is equal to 3/4, which is less than 1, the sum and there we go again. Why does this keep happening? The sum of or equation or sequence or series is equal to a, so 9 over 4 over 1 minus r, which is 3 over 4. So that's 1/4. Multiply by reciprocal, we get 9. 9. Yeah? Yep. The next up is going to be 35. 35 has integral from I instead of n this time. I equals 1 to infinity of sine 100 to the power of I. Well, this is another geometric series. So we go to sum of sine 100 times sine 100 to the power I minus 1, which is equal to, wait, what is sine of 100? Or R value is less than, no, R value is equal to sine 100. Which is, in fact, about negative 0.5, so this is less than 1. Therefore, or sum is equal to A, which is sine 100, over 1 minus R, which is 1 minus sine 100. There we go. Next up, 39. 39 wants the sum of the series Arctan. I already know this one's going to be divergent, because Arctan, the limit is going to be power over 2. Limits as n approaches. Again, please. God, what's happening? Why is there so much lag? As n approaches infinity of Arctan, n is equal to power 2, which is not 0. Therefore, diverge by Instern test. There's a lot of lag going on now. (41). We want the sum of the series 1 over e to the power of n plus 1 over n times n plus 1. So we need to express this as two separate sums. Plus the sum of 1 over, all right, the sum of 1 over e to the power of n, that is equal to 1 over e times 1 over e to the power of, or rather I need to put the sum here. Power of e times 1 over e. Not again. Why does Microsoft Whiteboard keep freezing up now? All right, to the power of n minus 1. And since r is 1 over e, which is in fact less than 1, this sum is equal to have to write very slowly or everything lags. One over e over 1 minus 1 over e. So that's e minus 1 over e. Wait. E minus 1 over e multiply. So that's 1 over e minus 1. And then the other one, the sum of n equal to 1 to infinity of 1 over n times n plus 1 is equal to the sum of 1 over n times n plus 1 is equal to, this lag is almost unbearable. How many questions do I have left? Okay, we have like 5 more. Equal to a over n plus b over n plus 1. And let's speedrun this. One is equal to a times n plus 1, or an plus a plus bn. So a is equal to 1, b is equal to negative 1. It's frozen again. Who knew Microsoft Whiteboard could be this resource intensive? Go to 1, negative 1. So we got a telescoping sum. 1 over n minus 1 over n plus 1. And let's just write telescope. This is equal to 1 over 1 minus 1 over infinity plus 1 equals 1. Therefore, our entire sum I'm gonna start a new whiteboard after this one. Or sum here is equal to 1 over e minus 1 plus 1. Which is equal to e minus 1, e over e minus 1. Okay, backseat polar curves. We've already finished with polar curves. Is this it? This is 41. This is it. This is the most convoluted questions we have so far. At least sequences, you have to kind of think about it. But hey, welcome back. Now let's start a new page. This page of the whiteboard is starting to lag so hard. I literally cannot write on it. A new board cannot be created. Please try again later. Please! No! No, don't betray me, Microsoft Whiteboard. Something went wrong. No! The whiteboard has betrayed us. Well, crap. Let's restart and see if that helps. Well, while that's happening, let's get a dad joke in here to listen up the mood. Don't know how you call it, but let's see. Open whiteboard. Can February, March? No, but April can. No, but April, May. That's not a dad joke, that's a pun. 0 out of 10, that's no dad joke. What's the best thing about the elevator joke? They work on many levels. That's a pun. That's just a pun. Dads don't ask questions. They give you answers, but Microsoft Whiteboard still does not want to work. I'm sorry, but we may be screwed. The Microsoft Whiteboard service is currently down. And we got 5 more questions to go. Oh dear, what other thing can I use? Why does it have to go down at a time like this? Oh, let's get an actual dad joke in here. What can you hear? Pterodactyl go to the bathroom. The P is silent. Oh, pterodactyl! That's how you pronounce it. Well, okay, this one gets a 2 out of 10. I'm very strict with my dad jokes. What is wrong with Microsoft Whiteboard? Please. What else can I use? Google Jamboard? Let's see. It does not want to work. All right. All right, this might work. Can I change background to black? Yes, thank you. Since Microsoft Whiteboard has decided to betray me at the last moment, we're gonna have to stick with Google. And how do I share this? Let's see. Window capture. And we take the Jamboard. Okay. And it's kind of bothersome. Let's do it this way. It should be fine. And you won't. All right. Hopefully you can see it. Let's take our white color. What kind of pen are these? Marker, highlighter, pen. Okay, this is enough. 43. 43 wants the sum of n squared minus 1. Wait, no. N from 2 to infinity of 2 over n squared minus 1. We can rewrite that as the sum from n is 2 to infinity of 2 over n plus 1 times n minus 1, which is equal to hang on. Two over n plus 1 n minus 1 is equal to a over n plus 1 plus b over n minus 1. Therefore 2 is equal to a times an minus a plus bn plus b. So let's say a is equal to -2. Wait. 2 is equal to a plus b n plus b minus a. B minus a equals 2. B plus a equals 0. Therefore, b is equal to 1. A is equal to -1. Yeah? Yeah. So this is equal to the sum of a, which is, alright, so let's be b first. 1 over n plus 1 minus 1 over n minus 1, which is equal to, let's start at n equals 2. So we should probably do it the other way, to be honest. Negative 1 over n minus 1 plus 1 over n plus 1. Wait, no. Wait, that's... Huh? 1 over n minus 1 plus 1 over n plus 1. Or minus. That's right. Now that's going to be equal to, plugging 2, we get 1 over 1 minus 1 over 3 plus n is equal to 3, you get 1 over 2 minus 1 over 4 plus 1 over 3 minus 1 over 5 all the way to 1 over n minus 1, or let's do n minus 2 plus or minus 1 over n plus 1 over n minus 1 plus 1 over n plus 1. Okay, so this is going to be 1 plus 1/2 minus 1 over n. Wait, why did I write? That should be a minus. Minus 1 over n plus 1 equal to 0 over 2. Yeah, 0 over 2. Should I write limit? All right. Well, let's go to the next one, which is 45. 45 wants the sum of 3 over n times n plus 3. So this is equal to, let's see, 3 over n times n plus 3 is equal to a over n plus b over n plus 3. 3 is equal to a to n plus 3a plus bn. A is equal to 1, b is equal to negative 1. So this is equal to the sum of 1 over n minus 1 over n plus 3, which can be expressed as starts at 1, right? Starts at 1. 1 minus 1/4 plus 1 over 2 minus... Wait, I think I already know the trick to this. That at 2 because the difference is 2. This is 3. So what if this is equal to 1 plus 1 over 2 plus 1 over 3 minus 1 over infinity plus 3 minus 1 over infinity plus 2 minus 1 over infinity plus 1. Wait, no. But this should be the answer since infinity is just 0. Minus 1 over n. Now n plus 1, n plus 2, n plus 3. Six, 11 over 6. If my guess is correct, this is 11 over 6. And it is. Ooh, I just figured out a shortcut to telescoping sums. Continuing on. 47 wants to sum e to the power of 1 over n minus e to the power of 1 over n plus 1. So that's going to be equal to e to the power of 1 over 1 minus e to the power of 1 over infinity, which is equal to e. That can't be a wait. No. Minus 1. E to the power of 0 is 1. Oh my god. I just figured out the shortcut to telescoping sums. Next up is 53, which says 2.516 two fractions. All right. So this is equal to 2 plus 0.516 times 1 over 1,000 to the power of, I forgot the sum part. The sum from n is equal to 1 to n is equal to infinity of 0.516 times, rather this would start at 0. Let's say 1 over 1,000 the power of n minus 1. It is equal to 2 plus 0.516 over 1 minus 1 over 1,000. Oh my god. Well, now we need to get this as fraction. 0.516 divided by 999 times 1,000. Wait, no. That's just 2 plus 516 over 999. 9 times 2 plus 516. This is equal to 2514 over 999. Wait, divided by 3. Oh, can still divide it. 8/38 over 333. Now for the next one, we got final problem 55. 1.234 times 567 bar over 567. So this is equal to 1.234 plus the sum from n equals 1 to infinity of 0.000567 times 1 over 1,000 to the power of n minus 1, which is equivalent to 1.234. Let's do this. 1.234 over 1,000 plus 0.0000 not 0.0567 over 1 minus 1 over 1,000, which is equal to 1.234 over 1,000 plus 567 over 1,000 over 999. Multiplied by 999 on both sides. It's probably something like this. Yeah. Can I divide? Huh, no. So do some math wrong. Divide by... No, that's right. But how do they simplify it? Oh, it can divide by 27. Divide by 27. You get 4, 5, 6, 7, 9 over 37000. 4, 5, 6, 7, 9. That's right. Oh, that's done. Is Microsoft Whiteboard functional again? Nope. Microsoft Whiteboard is still down. Well, okay. Before we say goodbye, let's get one decent dad joke in here. Come on. What musical instrument is found in the bathroom? A tuba toothpaste. Okay. That was another pun. What do you call a fish with no eyes? Are these all just puns? Can we get some quality dad joke here? No, that's not enough. The hell's a cantaloupe? What the hell's a cantaloupe? Oh, it looks kind of like a melon. Oh, it's those sweet melons. That looks orange. I like those. Are fish so easy to weigh because they have their own scales? Come on. What they call corn that joins the army? The kernel. That one, eh. Two parts are sitting on a perch. One turns to the other and asks, "Do you smell fish?" Oh, a perch! A perch is okay. Perch as in a fish. Writing with a broken pencil is pointless. Okay, that one, alright. I'll accept that one. You got a good dad joke right there. You're lucky, you got the good dad joke right off the bat. I had to spam the command like 10 times before it gives you a half decent one. But alright. The torture session today ends here. Indeed. I don't know if it can scroll up in chat, but I've been trying to get a decent dad joke before I say goodbye. And you got it for me, so thank you. Streamlabs? Oh, Stream Elements. Stream Elements is not the same thing as Streamlabs. Streamlabs is a OBS software that I ripped off of the original OBS. And Stream Elements is just like a little plugin for OBS. I do not like Streamlabs. The API I'm using for the dad jokes is okay. I will leave it at that. Hopefully Stream Element does a better job of coming up with dad jokes. He probably can't do it right now because he doesn't have a family. But hey, this is by far not the end of torture. We still have what? About 6 more chapters to go. Aside from that, hey, have fun with the rest of our day. Yoink!